Okay, so I'm sharing with you the screen that is going to be like recorded on the item. So I was actually just able to open up the lab, just how you're gonna see it. Okay.
Okay.
So first steps first, right? We have to like type in how much, what is the information that is given to us. So in this case, the mass of an empty evaporating dish is 36.402. So 36 grams approximately.
Mhm.
Then it says you have been assigned an unknown number 2. Enter your unknown number. So, well, got unknown number 2.
Mhm.
So, next. Um, enter your unknown number. Okay, we did that. Mass of the evaporating dish and an original sample. So now we have the dish that weighs something, plus we have the original sample with the dish. So dish plus original sample, right? And that is 37 point, whatever that is, 37.272. Okay, we went up at least a gram, or around a gram.
Mhm.
All right, mass of evaporating dish number 1 and sample after subliming the NH4Cl. So that means that at some point we heated this, right? And our solid started turning into a gas, right? So we had some stuff escape. And now we have just slightly less, as
Mhm.
you can see in the numbers. All right. Mass of the, so this is a different trial. And I think that's why I didn't input anything, because it makes you go through all the trials.
Mhm.
2.47. Okay, just repeating. Because in any time you're doing an experiment, it's always good to have 3 trials. So if you're ever in an actual lab
Mhm.
and you have to repeat an experiment, repeat it 3 times and then take your average. Okay, you have reached the end of, okay, so we've collected all the data that we need to collect, right? So we're
Mhm.
gonna proceed. The wonderful thing is that it actually tells us on the side like what our numbers are.
Mhm.
So we don't have to constantly like go back and forth to try to find the information. Um, so, dun, dun.
So
Okay.
basically, you're plugging in the numbers of what it says, like on
Mm-hmm.
the scale. Okay, I
Yeah,
get it.
so those were
Yeah.
all our weights. That's everything it weighed. So, okay, so let's look at the first one, right? It says oh my gosh, mass of the evaporating dish. So this is how much our evaporating dish weighs. I'm just gonna write that down on my notes. Okay, so it's always good. You have to turn in notes at the end of each lab. So
Okay.
make sure that you take either pre-lab notes or you take really good detailed notes on this,
Mhm.
not just like a sentence or two. So the first is the mass of the dish, right? The thing you're gonna weigh it on. And then we have the mass of the dish and the original sample. All right, so it's asking, what is the mass of the original sample? How can we find the mass of just the original sample? Don't overthink it. That's one of the things people do. They overthink it because they don't see they're like, it can't be simple.
I'm gonna say like you subtract
That's
the.
a yeah. That's
Okay.
exactly what you do. Hi, Alondra. You're gonna subtract the mass of the dish with the sample from the mass of the dish, right? Because if you
Mhm.
get rid of the mass of the dish, then you're just left with the mass of the sample. So
Okay.
we're gonna take the 37.272 minus the 36.402, and we end up with 0.87 grams. So in my experiment, at least.
Mhm.
That's how much I have, right? After subtracting these 2 samples. So the next question is, what is the mass, or the mass of the evaporating dish, number 1, and the mass after subliming was this. What is the mass of NH4Cl? So we want to know, what is this mass right here, right? How can we find that out? Another simple one.
I'm gonna say subtract again.
Exactly, subtract again. So we're going to subtract this from which one? This original sample or from the evaporating dish?
See, that's where I get confused. I'm gonna say from the original sample.
Right, well, if we did the original sample, you would still have another weight there. being added, and then that would be your evaporating dish. But it might work because, as you can see though, it will eliminate your evaporating dish as well. So actually both of those methods would work. If you take this minus that, you're going to end up with a difference, right? And that's the
Like
difference you want.
You mean like a negative?
No, it's not going to end up being a negative per se, because we just want to know what the mass is. So the negative number you're thinking about, that's what's sublimed. That's the gas. Okay? And it's not exactly negative. It just means it went away. Okay. So in this case, we want this number here, so it should be a positive number. The other way to do it is to take this number here and just subtract the mass of the evaporating dish. So let's do that. Let's do the 37.148 minus the mass of the evaporating dish, 36.402. And we end up with 0.746. It's like if I wanted to say, like, I want to take your weight, right? How much do you weigh? And I weigh you with your shoes and your coat on. Okay. And I still want to know how much you weigh. And I know that the coat weighs 10 pounds and your shoes weigh 5 pounds. All right. And so if your weight was like 160 with those two things on, to find out your actual weight, I have to subtract the 10 pounds from the coat and the 5 pounds from the shoes. And that's what we're kind of doing right here.
Okay.
Alondra, if you have questions on this as well, by all means, this is what the session is for. It's just a quick like Labflow kind of thing. Feel free to ask. Okay, so now we want to know the percent by mass of NH4Cl. So what equation did you get for the percent of mass? Well, let's say you're lost and you don't know, right? Our labs, they all have a PDF. So like you have the separating mixtures, they all have this PDF, they have the videos, the pre-lab, and then your report. So we always turn in the pre-lab and the report, and a lot of people tend to skip all of this, right? But the PDF actually guides us through everything that we need to do the lab. Right? It can give you step by step. So here we can find out what is the percent of the component. Okay, so this is telling us that we need the mass of the component, which is the NH4Cl, divided by the mass in sample in grams. The mass of the sample. So another way I like to, and times 100. Another way that I like to remember these kind of equations is saying it's the part divided by the whole. So the smaller amount, or the part, doesn't always have to be smaller, but the part divided by the whole. Okay, so if we go back here, oops, made this super big. Okay, remember that we had the original sample, right? And our original sample weighed 0.87. That's the entire sample, 0.87. So my mass of my sample weighed 0.87. Is that going to go on top or on the bottom based on the equation?
At the bottom? Yeah.
Yeah, it's going to go on the bottom because it's the mass of your actual sample. Okay, and then the amount that we recovered, or in this case, this was the amount recovered, or the mass left over, right? That's going to go on the top because that's your part. So our part is this number right here, 0.746. So you're going to take your part divided by your whole times 100.
I had a quick question.
Uh-huh.
Do we need to purchase a specific calculator for this?
No.
No?
No, you don't. We only do, like a scientific calculator would be very helpful, but you could get away with not having one, but you just have to know how to manipulate your equations and kind of derive them yourself without a scientific calculator. So, for example, scientific notation, which is like if you have something to the -5 power or the -10 and you're dividing them, there's really good tricks, and I think I show them in Module 2 on how you could solve those problems without a calculator. But if you want to make it faster, just get yourself a regular calculator. Nothing expensive, nothing like that. Like I have this like cheap Casio, you know, and I have other ones that I've used throughout the years that as long as they has log and like an EE function, so that could like your power function, you should be fine in this class.
Okay. And then another thing too, I know you mentioned to remind you to record or screen record your.
Oh, I'm recording, right, Brianna? I clicked record. Yes, I'm recording right here.
Okay.
There it
Perfect.
is. Okay. Whew. I'm like, oh my gosh. Yeah, right. No, the little figure right here, this is my Screencastify. It has a little red dot, so it shows the recording. Thank goodness. Yeah. Brain moment. Okay, so I was doing that times, oops. Let me delete that really quick. All right, and I got 85.7%. Okay. So that's kind of how you do the little math for all these little sections. And then you're going to repeat that math for your trial number 2, right? And it's going to come right here and you're just repeating it. Then you're going to notice that it's going to be something similar, but it's going to be of silicone this time, right? This one is of trial number 2 is of sodium chloride. It's giving you the information, you know, evaporating dish. This one's a little bit different. It actually gives you the mass of the evaporating dish, you know, all on its own. And then it's saying mass of evaporating dish number 2, the watch glass, and, oh, it was a watch glass, sorry, not evaporating dish. So it's 2 different things plus your sample. So in order to find the mass of your sample, what should we do? This is everything, right? This is evaporating dish and a watch glass. So remember, it's like your jacket and your shoes plus the sample. So if I want just the sample, what do I do?
Subtract that number with the sample.
Yeah, subtract the evaporating dish mass, which is 36 here, and subtract the watch glass mass. Subtract those 2 from this number, and that's going to give you your sample number. Let me see if it
So
lets.
it's basically just kind of repetitive.
Mm-hmm. So it would be the, oh, it lets me write 66.132 minus, you know, I'm going to call this A and I'm going to call this B, minus A plus B. And you could do that math, you could show it differently, however you want, right? Because A is this number, B is that number, or you could just say this minus that, you know, carry the negative inside if you want. It's just different forms of the algebra. But yeah, you're just subtracting, it's repetitive, and whatever answer you get, boom, right there. And that's going to be the mass of the sodium chloride on its own. How do we do the mass percent again? What did we do for mass percent? What goes on top? What would you normally put on top? Do you remember what I said helps me remember? Is it the whole on top, or does the whole go on the bottom? Don't be shy, you guys.
I'm gonna say the whole goes on the bottom, but I'm not quite sure.
That's correct. So it is the part. So this is what I was saying. It might help to see it. The part divided by the whole times 100. So the whole is the entire sample. Okay? The entire sample is your whole. The part is just what was left. Okay? What was left from your mixture. Okay? So if we need to find out what is the whole, right, we go back to the original sample and we try to find that number. So it won't let me move because I'm annotating. Let's see. All right. So you go back to the original sample, which was your 0.87. That's your whole, because that's the original sample, and your original sample is a mixture. Okay? It has tons of things inside of it. It has NH4Cl, it has NaCl, and it has zinc oxide. Right? So you want to know how much of each of these mixtures is inside your whole. Right? So you always go back to the original sample as your whole, and then the part is what are you looking for, right? What are you actually testing for at that point? You know, your focus. So in this case, sodium chloride is your part. So whatever you get here for mass of sodium chloride, that's your part, and then divided by the whole, which was your 0.87. And then you're going to repeat that for the silicone dioxide. You're going to take your mass, your part of the silicone dioxide that you found, and divide it by the whole. Let me erase all this. It looks bad when writing. I'll let you guys do that, you know, and then you could ask me some questions, and then we'll move on. So do that, those two on your own. But if you get stuck, let me know. You could also write it in the chat if you don't want to like ask your question and be on the video. The chat box is not on the video. Neither are your guys' names, by the way. It's not on the video. So the only thing on the video is my Labflow sheet. How old's your baby? Your baby sounds like a newborn.
So since yesterday, I've been having trouble logging into the Labflow.
Mm-hmm.
And then now I'm having trouble with the Chafee login. It says there's a request error.
I like
and I'm trying
to get on your canvas.
Yes.
Okay, so what exactly does it say?
So when I'm trying to log in for my Chafee account, I'm signing in to go into, you know, Canvas and my portal and stuff. It says there's a request error.
Request error.
Yeah, SSO request error.
Okay, is there a contact support button on there?
I'm going on the page. And then I restart my computer, and then somehow it works, and
okay, here.
So forth. Yeah.
I think we'll go over it. I'll try to help you with that, and I'll finish going through this so that way the video is short, and then we'll turn this off and I'll help you. Okay.
Okay.
As best as I can, because I'm really not an IT person, but
yeah.
I'm so cute. All right. Okay, so, all right, after you put in your information, you find out, like what's what. So we got massive evaporating dish, and sand. So then you're just going to subtract these two and you end up with your sand. Sand is actually silicone dioxide. So that's kind of something neat to know. So you got your silicone dioxide right here, of your mass. And then you want to know the percent mass. So you're going to take the part, what you just found out, divided by the whole, which is your original sample. In my case, it's the 0.87, right? So I think we're kind of understanding that, right? We take the part divided by the whole. Okay. All right, it's like saying you have a pizza and you have 8 slices. 3 slices have jalapenos on it, and 3 slices have olives, and 2 slices is just cheese. And I want to know, well, how much of it's the part over the whole times 100 would give me the percentage, right? So if I want to know how much cheese pizzas I have, I'm going to take 2 divided by 8 and times it by 100 to get the amount of the percentage of cheese pizza. So it's the same thing we're doing here. We're just taking the part divided by the whole to find out what we have. All right, so now we're going to move on to calculating the percent recovery. So again, when we need help with these, like our PDF actually provides us with very good information. I kind of wish it would just put it on a whole screen. But if we want to know the percent recovery, we're going to take all the individual masses that we just found, add them together, and divide it by the mass of the original sample times 100. Okay? And we want to know, did we actually get 100% of everything, or did we get a little bit less? Okay, so that's going to be your next step, is to take all of your masses and divide it by the mass of the mixture. So here is, okay, where are we at? Okay, mass of the original sample, which we had like 0.87. Experimental mass determined. So we're going to take all our individual masses and add them together. Now, I didn't do that obviously, but I know that this one is 0.746. So I'm going to start with the 0.746, and then I would say plus whatever the sodium chloride was, plus whatever the silicone dioxide mass was that we found, right? And then we're going to, it says differences in these weights. So to report the value of the difference, right? This one's a little bit different. So we're just going to be subtracting the weights and find out what is the difference between these weights added together minus the original sample. Okay, so add all of these together. That's going to be your number that goes here, minus the original sample, and that number is the difference in the weights. Okay, we're good there, right? I'm just going to assume yes. All right, so now the next part is the percent recovery of matter. So you want the mass of recovered material divided by the mass of the original sample. So you're going to take all of this and divide it by this. So this one was subtracted. Now this one you're going to divide them and multiply it by 100, and that's going to give you the percent recovery of matter. And you're going to put that one there. And then the rest of this is just a couple of questions. Then you're going to download all of your work, show all of your math, your equations. Make sure it's nice and neat so that way it's easy for me to read and go through it, and upload and submit. Okay. I really hope this helped. Do you guys have any questions on anything that I just said about this part of the lab? I'll just write, this one is going to be original sample minus the sum of all the substances in mixture. All right, you can't read that, but everybody could replay the video. Original sample minus the sum of all the substances in the mixture. And this one right here is going to be, well, the mass of the recovered. So this is the sum of all the substances in mixture, right? So those are all the parts divided by the original mass, right? And then you're going to multiply that by 100, whatever you get by 100. I really hope this really helped clarify any kind of the questions that you guys might have had in the lab. All right, with that, I'm going to go ahead and turn this off.